Hey guys, how you doing today? Well, Greg right now is gonna join late, so I'm gonna start today for this particular episode. And what we wanted to do is to now have a different perspective, try to use a different language with CockroachDB, and in this case, we're gonna use the power of Go, right? So we are going to create the same kind of application that we've been doing with Java and Spring Boot. Now we're gonna do this with Golang. So what about if we start right away? So let me do a present. So I'm gonna share my screen, and I'm going to guide you. I'm gonna guide you practically on what you need to do in order to actually have your application written in Go connect to CockroachDB, right? So remember, we've been chatting about on the past episodes all about what CockroachDB is and what are the features and all that kind of stuff. So practically today we're gonna use those features. We're gonna use at least one feature, kind of the same thing as we did in the past episodes with the Spring Boot, but now in Go. So this is how normally I want to set up my environment. As you can see, I have here my terminal. And normally what I like to do is always kind of a show a kind of my path. Where are my, in this case, a Go requires to have the Go root where you have located your Go compiler and all the libraries. And of course, you need the Go path. So if we do the echo Go path, this is my path. And as you can see, I normally like to do users, progs, langs, Go code, right? So I have, this is my Go lib, this is the first one, and then I have the Go code. So on the Go lib, every time that I want to install something that is going to be a binary, that's the first thing that the Go program is gonna say, you have the Go lib, so practically we're gonna start installing everything there, your packages. And if it's everything about source code, something that is kind of a new, practically is gonna kind of a search pad is gonna try to look into the code. So I have this. I already am in my. This is my path. So as you can see, I already put like a this kind of a convention that I've seen with Go. Is like you want to put your a whole a repository, right? So it's going to be easy to pick up and easy to practically grab from the internet and download it to your machine. So practically, this is what I have. So we're gonna start leaving on select start show, right? So this is my actual path. So what I'm gonna do is I'm gonna create first a directory name payroll. So we're going to do the payroll again. Um, we're going to do this kind of an employee payroll application. Very simple. And the only thing I want you to demonstrate today is how you can connect to CockroachDB using Go. So once I have this, I need to go to the payroll, right to my repository. And from here, what I'm going to need to do is just go and do the go mode init. And normally I put the whole path, right? So my module is actually having the whole kind of a string, right? From the GitHub, from the selected start show, and the payroll. So if I do that, practically what I have is just my Go module, right? Now from here, what I like to do once I have this is practically do the Golang part where I'm using this editor. You can use whatever editor you want. The only thing is that you need to be able to set up your environment with the Go path and Go root where the Go is located. So in this case, Golang, what it does is automatically checks out and review and take a look. You already detect, hey, you're using Go 124.2. That's your SDK. So let's start working on that part, right? So the next thing that normally I like to do is just as before we did in in previous episodes, um, normally we start installing the dependencies. That's the first thing that I need to do. So the next thing I'm going to do is I'm going to open a terminal. So from my terminal, so I'm going to practically, I'm going to copy this. I have my cheat sheet over here. So I'm going to copy these big kind of dependencies, but I'm going to show you what that looks like. So it says, hey, go and get from GitHub the UUID from Google. Also, we're going to use GORM. GORM is an ORM library for Golang, right? So if you're familiar with, for example, Hibernate or iBuddies or MyBuddies, actually, or the other in Java frameworks, or even on for example, on .NET, they have the ADO.NET, regular SQL, like a very native SQL, or you can use the EF core. That's actually the ORM part, right? Like object relational mapping. So we are going to use that, and for that we're going to use also the Postgres driver, right? So it's important to know that CockroachDB, its SQL layer is based on Postgres. So practically we can do SQL and use all the features underneath CockroachDB. Then we're going to use a web framework, and this web framework is actually named Gonic. So it's a Gene web framework that allows me to create REST API applications. And finally, we're going to use this kind of figure thingy that I found in the past days. I wanted to emulate the same thing as when we start an application, just a regular ASCII banner, just for fun. I mean, it's not necessary to have this, but it's just for fun to emulate what Spring Boot is doing well here in Go, in this case, right? So that's the only thing we're gonna need. And as you can see, it's so fast right now because I already have these dependencies in my code library, right? So practically they're already there. So once we have this, the next thing is practically start with our application. So in Go, I mean, if you are new to Go, something that you normally like to do is, well, you're going to create your main application, right? So if you're going to go and create your main, by default, in order to start an application, you're required to have a package main. That's the way that Go recognize, hey, this is my entry point. So practically, I'm going to need a function that is going to start. So we're going to create the fun main instruction to start our application. But I'm gonna come back here. I'm gonna show you how easy it is later on. So the next thing we're gonna do, we are going to create a new directory, and this directory I'm gonna call that models. So we are going to create our models. Again, very similar on what we did in the past. So we're gonna go out here and we are going to say model, just model. Right, on this model, as you can see, is package models. So what I'm going to do is I'm going to create an employee, and an employee has this particular structure. So let me explain to you what this is, right? So practically, I'm going to try to zoom on this. So I have the employee is going to be a type of struct. And I have these three fields, an ID, a name, and a role. Now take a look that I'm using the UUID that is part of the Google library. And that allows me to actually create a global unique ID, right? Now, in Go, for the newbies, practically Go allows you to tag every one of these fields with custom tags that allows it to be processed after, right? So in this case, something that Gene recommend, the Gene web framework, or and even GORM is, what about if you put like the JSON tag and automatically I'm going to convert whatever you have on the structure into a JSON format. Now GORM uses this particular tag that says, hey, I'm going to use the GORM tag, and this particular ID, please, is going to be type of UUID and is going to be your primary key, right? So we're gonna leave these like the employee, and we're gonna come back here later. So I'm gonna explain this. We're gonna start using UUID. I think this is a kind of a crucial part um, of using, in this case, a global unique IDs, because I don't know, probably you are used to do auto increment, and there's something that doesn't play along with in this case with a multi-region kind of a databases, right? So this is something that you need to do. Like for example, why kind of the question is why auto increment integers are a problem in distributed systems. Well, first of all, in a single node a bottleneck, kind of the auto increment primary keys are inherently sequential, meaning that a single source, kind of a node or a range, needs to coordinate the next ID. So this becomes a hotspot, one node getting hammered with writes, right? Also is going to bring this poor scalability. You don't need to get parallel write across nodes, since all roads when the Christian IDs go into the same range, right? Until that range splits. So remember that CockroachDB, again, in the past episodes, we were talking about that the way that it connects your data is through ranges, right? So that's why it's kind of a important to know that probably our increment integers are not the right solution here. Now, rebalancing delays, right? Kind of that hotspot delays CockroachDB ability to rebalance the data effectively. So that's kind of the important keys. And another is kind of an inconsistent performance, right? Meaning that a more writes go to a single range, your performance may degrade over time, right? So that's kind of the idea. Now, why CockroachDB prefers UUIDs? Well, first of all, it's global unique, right? It's randomly distributed, meaning that writes narrowly scatter across node and ranges, avoid hotspots, better for write-heavy workloads, and then you have the safer for replication and eventual consistency. So that's why UIDs solve that in CockroachDB, right? So, and of course, there are some trade-offs on UID. Yes, it's going to come with larger storage. Of course, there's going to be a slightly slower indexing at some point. Probably it's going to be harder to debug, right, and read manually. But at the very end, the benefits for scalability and performance for outweigh the downsides is practically, especially for large distributed deployments. So that's part of why CockroachDB requires or kind of promotes more the usage of UID. By any means, I mean, you can still use auto increment, but the recommendation is to actually use these kind of scenarios. All right, so we have our web part. Now, hey, Gray.
Hey, how's it going?
Good. How are you?
Excellent. I was tied up in a meeting that ran long, but I was like, quick, okay, I got to get over here, man. I'm missing all the good stuff. So
Yeah, when the intro it was like Greg Turnquist and voila, I'm here. I'm like, oh no. So
we
maybe
wrote that, yeah, and for everybody's amusement, we wrote that back in September last year before when Felipe was just a speck in the eye. And so now that he's here, I'm like, we need to go back to our video editor and we need an update.
yeah, we need to modify it. Very good.
That's right. All right. We'll
All
take
right.
it.
So let
Dig
me
back in. I
continue,
want to see
guys,
this.
with this. So the next thing that we're gonna do, we're going to create the repository, right? So we're gonna create a repository directory. And inside this directory, once we already have our model, so the next thing is to talk about database, right? So we need to kind of somehow tell our program, hey, this is my database. This is what you need to do. So practically, this is what we need. So let me explain what is doing this particular code. First of all, there is a variable, kind of a global variable, that is part of the GORM DB. So practically, that's the the underneath technology that we're going to use. And then we have something that I like to do all the time is kind of try to emulate some of the good practices that Spring Boot brings to the table, or the Spring framework, like a forever. It's like you can use environment variables or your application properties, right? So in Go, we have kind of the same thing, but I didn't want to put too much effort on the properties, but I like to do this environment variable. Practically, if you provide the database URL, you have control on where you want to connect. If not, by default, we are going to connect here. Now, take a look that we're using the Postgres protocol. Remember, the CockroachDB uses Postgres, part of the layer of the SQL. So that's why we need to connect. Right now, it's just a demo mode. So practically, we are going to have only one user, the root. It's going to connect to a local host, and this is the port from CockroachDB, right? So 26257. We're going to use the payroll database, and it's going to be disabled on the SSL mode. So in this case, GORM, it says, hey, I'm going to open your progress based on your name. You can have some extra configuration here. We're not going to talk about today on this configuration, but you can have multiple configurations like a transaction, more on the how a cockroach, how GORM can operate into your database. If there's any error, remember that in Go, one of the cool features is that it can return multiple variables. So practically you have this, and if there's an error, I'm going to log fatal, and practically the database will be that DB that is already here. So that's very simple, but that's kind of the way to go. Now let's create the actual repository. So this is kind of I can say a manual, kind of a wire up that we need to do with Go. So in this case, I'm going to create a new repository. So I'm going to create a repository, and something that I need to do first is something very similar like Spring is doing. I don't know if you remember on a Spring Boot, and of course Greg is here, but on a Spring Boot, normally you have to implement or extend from a repository. So you create an interface, and that interface extends from the CRUD repository and all that kind of stuff. Here in Go, we don't have these parts. So practically what we have is a way to say, hey, this is going to be my interface. And I'm going to copy the same, again, I have the same idea as an JPA or JDBC data and all those goodies from Spring. So that's why I'm using this. I've seen other developers to use different naming convention, different ways to do a kind of the persistence of the data, right? Like a create, like a find, like a get all, and all that kind of stuff. For me, I'm trying to follow some of the practices that I've been, working for like forever, right? Now here, this particular repository, even though it's a particular contract and interface, it already has a direct way to connect to our model. Maybe you're wondering, well, what about if we extend this maybe, or maybe we can do some generics on this? Yes, you can do it. But I want to show you right now the simplest way, right? So if you go with generics, yes, you can reuse this repository and practically use in any kind of my thinking is that you are creating the same work that already, for example, Spring JPA already offers, right? Once you extend from an interface, you don't need to worry about the save, the find all, the delete, or the update. It's already done for you. But in this case here, in Go, you need to do it yourself, right? So at some point, they give you a kind of a control, so you can do more stuff, right? So yes, we have our contract. This is our repository, and now we need to implement it. How can we implement it? Normally, what we do is we're going to do an employee repo. employee repo, right? And this employee repo, what it does is just an struct that is going to have the database that we are going to need. Practically, we need to inject that database into this repository. It's the way to say, hey, I already have the connection. I don't know if you remember. On my DB, I have the connect to database. We're going to see when we're going to call it. Once we call it, we actually put this right here into the employee repository, and then we need to work over this employee repository. So practically, what I'm saying is, hey, I have already my contract. That's my interface. I need to implement it, but for that, I need to create my struct. It will be the similar as creating a class, for example, in Java. So you have your class. This is your interface. And normally in Java, you say the name of the class. So public class employee repository implements the name of the repository. Here in Go, it's a little different. So here we are going to do all the implementation. And for that, I'm going to paste practically all the repo implementation. And we're going to go kind of a one by one and see, this is my implementation on this, right? So first of all, I require to have, let me put this, I require to have a kind of a new employee repository, something that I need to actually create the instance. So for example, in Java, normally you say the name of your variable equals new, and then the name of your class that you are working on. You're passing maybe in the constructor part of what you need, right? Like the dependency that you need. And in this case, in Go, there is no new, but you can emulate that with a function. So you practically say, hey, I'm going to say new employee repository. I'm going to pass my dependency that in this case is the database itself. And practically, I'm filling out this class. Now, the implementation of the say, find all, find by, delete, update, and SQL query practically comes here. One of the cool things that you can do with Go is that, hey, this is the signature that you need. In this case, this is my structure that is implementing the save, the find all, and the find by. And the cool thing, again, is that you are able to return tuples, or in this case, multiple values, right? So let's take a look into the create. Let's review the create. So once I have my employee, what I'm doing is I'm gonna go to my repo, right? So my repo is actually this guy right here. So my repo is this employee repository. This is the one, .db, meaning that this is going to be the database that I already have. And the cool thing, because this is GORM, already GORM knows what to do with create. So we're going to do create, employee, and error. So the create practically is going to, we're passing an reference of the employee. So as you can see, this is a pointer. We're passing this as a reference. So everything is going to be created and is going to be filled out on whatever other values it needs from the database, right? So it's going to return that, or it's going to return an error. Now for the find all, it's very basic also. So you have a repo, meaning that you're calling the GORM, the DB, the find, and you're passing the employees. Also the employees are, in this case, an array of the model employee, and you're passing your reference. Practically, one of the cool things about Go is that you can use pointers and reference, so you don't waste time on copying the whole value, right? So it's not copied by value, it's kind of a doing by reference. So that allows you to have a better performance. Find by ID is practically the same. In this case, they have first, and the first, you pass the employee and then the ID. You need to pass what you are going to fill the information with. So you're passing the ID. In this case, it's a UUID. And then once it's found, it's going to fill out this employee and you can return it. Or if there's nothing there, practically it's going to return an error. And then the delete, also simple. hey, we're gonna delete of this instance just by ID. This is going to be the update. Check out here that we're using something different. GORM has this difference between create, that's for the first time, and then we have the save. That means that this is going to be an update behind the scenes. This is using an update statement. Now, in previous episodes, Greg shows that on JPA, JDBC, you practically are allowed to use a truly native query. How can you do that the same in Go? Well, in Go, practically you have this, something that it calls raw, meaning that you can pass your query, you can pass your values. It's going to do the scan. This is just a way to say, hey, this is what I need to do. This is kind of the way to say to the SQL database, the DB, hey, I need to have this particular query being executed, and everything that is related, just do it and put it right here into the employee. So if you want to use SQL statements that are your own SQL statement with joins, with special functions, practically you need to use raw in this case. That's why I put it a SQL query, right? So I'm emulating the same as in Spring Boot, you do the add query. You can do that, or you can create your own specific method, right? When you are extending from a particular interface. So you have, in this case for GORM, you have raw. So that's part, this is the whole implementation. So the next thing, we are going to do the controller. So practically, yes, we have the persistence, we have the repository, we have the models. Now let's do the controllers. And for that, we're going to create a new folder. I'm going to call it controllers, or let me see. In the previous, if I call it, yeah, we're going to call controllers. So in this case, controllers, I'm going to use the employee controller, right? So I'm going to do a code file. I'm going to do employee controller, controller, right? So I have my employee controller. So from this employee controller, the first thing I need to do is practically inject my repository. How can I inject my repository? If you remember, practically the way to do it is just to have your struct, right? So practically you're saying, hey, it's going to be my employee controller. This is going to be my struct. And I have a repository, employee repository, right? So remember, this guy already lives right here that has already the database. So we are covered on that part. Now, the same thing again, right? So if we want to actually instantiate this employee controller, we should have, there's no new, but we have the way to do like the new controller, right? Like a new employee controller, where practically you're passing, hey, this is my repository, this is my new employee controller, this is the way to create this new instance. It's kind of as you can see, you can say like this will be your constructor. So practically you're creating this helper function that allows you to create this particular instance that you need. Very good. Once we have, let's start with the create employee, right? So the first thing we're going to do is we're going to create our employee. So let's take a look. This is now we're talking about the Gene Web framework. And for that, one of the requirements for you is that your handler that is going to go to a particular path in the, when you put it into the URL, you have a variable path. And for that path, normally you require a context, in this case, the Gene context, that allows you to say, hey, okay, the Gene context practically has all the HTTP headers, all the HTTP requests, response, everything, right? So practically is the same as when we in the Spring Boot, when you do the address controller and we do the get mapping, practically it's kind of the same thing, right? It's a little different, but here is a little manual, and this is how normally you do it, right? So you do like a Gene context, and in this case, you have this create employee. So for this, we have the model employee. Normally, we are going to do a post, and for the post, we're passing a JSON. And the way that, in this case, Gene Web Framework recognize that, you need to actually say, hey, we're gonna bind whatever you are sending me with the employee. So practically, it's gonna grab that JSON and it's going to do that parsing, right? So it's going to convert that into an object or an instance. That's why we're passing the reference. And of course, if there is something going on, one of the responses is c.json, meaning that whatever I'm going to respond back, I can say, hey, this is going to be the about request, and then the message that you want to send, right? So I'm practically return. But if everything is okay, we can save it into the repository. Take a look that now we have the employee controller, we have the repo, right? And then we can do save. This save is from the repository, and we're passing the employee. So practically, if everything went well, you have the JSON, your stars created and saved. So that's the create employee. So maybe later on you can see the similarities, Greg, and we can talk about it at some point. And see the other.
No, this stuff's really cool. I'm
benefits.
I'm enjoying this. I'm getting my crash course in Go here. That's for sure. I don't have a lot of Go experience, but it's fun looking at this stuff. It's like I can see where it's like, oh, that's neat. The mapping onto the thing, binding onto it on Spring. You get access to the servlet context or something, which is, I don't know, pseudo analogous to that, but it's neat to see this. Like everybody needs a context, so I like this.
Yes. So for here, we're going to do the get employees. So we're going to do the find all. And again, as you can see, very simple. This is what it does. It's just find all. It's going to get the employee. If you have an error, you send back internal server error with this error. If not, you respond with OK and with all your employees. So the next thing will be let's see. We're going to do the find by ID. It's actually the same. Now take a look here. Normally on a Spring or a Spring Boot in your get mapping, and normally you put add path variable. But here, because we're using this particular context, the context has an access to the parameters to the query string. And in this case, because we are using the slash and the name of the variable, is going to look for this particular key UUID into the whole path, and automatically it's going to do, we need to do a parse, right? So the cool thing about the UUID is, remember, everything that comes into the URL is treated as a string. So practically we need to convert that string into a UUID. So that's the thing that we need when we do like a define ID, right? And again, the other are kind of the same thing. Now the next one I think is going to be the or we're going to do the next one. So it's going to be, this one is going to be the delete, and as you can see, also the same thing. It's going to be delete by ID. So we're doing the same. Get the parameter from the path, the URL path, and then you are going to parse it and you're going to delete it. If everything is okay, then status okay, and do a message, right? So this is a way to do kind of your JSON. For Spring, for me, this will be just a map with the strings, and that's it, right? So it returns, and Spring Boot already converts that into a JSON, right? So it's practically kind of the same thing. This gene.h is just a JSON kind of a format. It's just a map, practically. So that was the delete. So now we are going to do one of the largest one, and even though we're not gonna use it here, because this is the update. Take a look on the update. What I'm doing is I'm doing the find, right? If it's found, then you can use the name and the role, and then you can actually do the update. Remember that it was the difference between the save and the update. The save in GORM, it uses the create, but in the if you're going to do an update, GORM has the update, right? It has the save. has the same method that is actually used for updating your raw your information. So this is how it
Hey,
looks like.
we got a comment here. We got a great tutorial, three hand clappings here. So we're like
Very
we're sizzling
nice.
here.
All
Thanks.
right. So we're gonna do the last one. This control. This is the one that in the past broadcast we were doing a lot, right? So Greg was explaining this, and so I wanted to do kind of the same thing. Here is get employees by role. So you have your again your gene context. You're going to have the parameter. It's going to be a role, and remember, because the role is just a string, we don't need to parse. We don't need to do anything. And now take a look. Here is my query. So I have the repo, the SQL query, and I have select star from employees as of system time of minus 30 seconds, where the role is equal to whatever is the role, right? So this is one of the cool features that we can have with, sorry, I'm moving this too much, with CockroachDB. So maybe you're wondering why, what will be the use case for using as a system time? Well, kind of the idea is you can have a point in time rinse and auditing, right? So practically you can have a perfect foreseeing what your data look like at a specific moment, right? So you can actually say it would be great for debugging, for compliance audits, probably for recreating business events as they happen. So this is one of the cool features that we have. The other is that it has consistent reads in multi-region clusters, right? CockroachDB has multi-region. So that means that you have different nodes, and in different regions, your reads may be or might be eventually consistent or have some latency. So with these, practically you can do consistent reads at a pass time without coordination, meaning that you can have super low latency reads from follower replicas, kind of a read local, without blocking ongoing writes. So that's one of the cool features about that, right? About using these kind of scenarios. Now you can have disaster recovery and rollback. So if something goes wrong at some point by deploy, there's something going on with the rows, practically you can query an old state, export it, restore what you need, and this is the way to use this kind on disaster recovery, or kind of a testing time-based features, right? Like historical reports, debugging, those kind of things. And we are going to test, kind of do the same thing as Greg was doing before, right? So
Can I add a little, can I add a little clarity to some of that stuff? I just to make it clear, the cockroach DB is always consistent. Okay, so that there's a lot of subtlety there in the as of system time stuff. We're talking about follower. They sometimes call these follower reads or time travel queries, but when you query again, not all the replicas are caught up, and that's why with when you don't say as of system time and you do some select operation, it goes to the leaseholder because the leaseholder does have the current consistent state of that row. It is most up to date. But if you say as of system time minus 30 seconds, 30 seconds ago, all the replicas are going to be caught up to that state. So what we're saying is that minus 30 seconds ago, you can go to the closest replica for a quicker latency. So you can get the answer faster on what happened 30 seconds ago. So there's the trade-off. Either you may have to wait, maybe you have to wait 3 seconds if you're having to go all the way across to the other end from East Coast to West Coast to get the answer from the leaseholder. So you may have to either wait with a little bit of fixed latency up front, or you can reduce the latency if you're willing to accept an answer that's like 5 seconds old or 10 or 30 seconds old. So that's how that works. And it has the side effect of, okay, what about an hour ago? Maybe I want to ping something. And then the ancillary benefit is also that 30 seconds ago, transactions have been settled. So you're not also competing with, are there transactions in flight that are blocking you? The state of the database 30 seconds ago is there's nothing transactional. So it cuts down on the number of locks that have to be used.
That is correct. Thank you. Thank you, Greg. All right. So the next thing we're going to do the application. So practically we're done with this, but now we need to wire up, right? So yeah, everything is there. So now how can I actually do it? So I'm going to create a directory named app. And then of course the app, when I create that one like that. And then I'm going to paste the whole app. So and we're going to go through each one of these things. First of all, the kind of the joke here to do the same as Spring Boot is doing when you start like your ASCII art. This is a very cool library that I found. So I mean,
Of course.
you don't need this, but it's very cool to see it. Now, let's take a look into the database. So remember, there is the repository connect database. Now, there's something that, again, for the Go newbies, every time that you found, or every time you find a function that it's starts with capital letters, that means it's public. If this is lowercase, that means it's private. So in this case, if you put attention on that, the connection database is with capital C, meaning that it's going to be public, available, right? So you are able to go a particular package and say, hey, I'm going to use this particular function, right? So then you need to start working with the visibility of the packages and all that kind of stuff. That yes, you can do it, and you can start doing this kind of a very cool and interesting projects that allows you to have that security, right, at some point. So in this case, we have the connection database, and remember that the repository package, or in this case, the file has a global variable named DB. So that's why we can do repository DB auto migrate model employees. So what it's going to do here is going to do the same as the JPA was doing on Spring Boot. And the Spring Boot JPA is going to recognize all your repository interfaces, and it's going to take a look into your class, your domain class, and automatically remember that we have the at entity, right? So automatically those classes are going to be auto-created in JPA world. So here, GORM is doing the same thing with auto-migrate. So auto-migrate practically is doing the same thing, meaning that this part is going to create the table employees, right? So that's one of the cool things that it's going to do. And of course, remember, we have the repository. We are wiring up right now a new employee repository. It's going to be the DB, and that's the employee repository. Now, take a look. I'm doing a database initialization. In this case, I'm saying, hey, I'm going to save two, like Felipe, an advocate on role, Glenn, an engineer, and later on, we're going to add more employees here. And I know that Greg is fan of the Lord of the Rings, but I'm not good with those names, so I switched to mortal names, right? So that's why.
I told him, I said, Felipe, make it your own, man.
All right. So next, we need to wire up the web API. So in order to do that, remember, we have this new employee controller. Remember, this one is the one that has already we're injecting the repository. It's like we're doing the auto wire in Spring Boot or in Spring. Practically, we're doing this manually, but this is the way to go. Here you go, right? So controllers, new employee, you pass a repository, you are injecting that dependency, and you have your controller. So with this controller, practically, you say to the gene, hey, I'm going to create the default, practically do this particular, the web group is going to be API. And take a look, with this API, I can do a post, get, delete, and put, and these are going to be my handlers, the controller, the one that you already know. And remember, as a kind of a rule, is like this controller don't create employee, get employee, find employee by ID. All these must have the gene context, right? So that's how it's going to work, right? It has this particular way to implement this particular or has this handler as a mechanism to actually process the request. So we have the path employees. Take a look that in order to put the variable, we need to do the colon and then UUID, right? So that will be the way. And for example, employees recent role, employee colon role, that's for the get employees by role. So that's how's the web API. And finally, we have this get environment. Again, I want to do kind of the same thing. This is going to be a port. By default, it's going to be the 8085, and it's going to run just with this automatically my application start. Now, let me show you something kind of very quickly. As you can see, this is an init function. And one of the cool features on Go is that Go doesn't have constructors, but allows you to have an init function per package or per file. So when you call something outside, automatically is going to execute the init. So meaning that if I call start, practically this is going to be executed first. So in other words, if I go to the main and I'm doing I'm going to do the function main, func main, and I do the app dot start, that's the way to go. So practically, this is the way that my application is going to start. So it's going to call this particular app. It's going to go to this start, but because this particular file has the init, everything under here is going to be executed first before the start. So that's how it looks like. Now, I want to get back very quickly to my model. I don't know if you remember in my model, I have this particular UID primary key, right? So I have this UUID. By default, GORM is going to say, yeah, this type is going to be a UID. It's going to be a primary key. And even you can say, hey, execute by default, generate the UUID if that doesn't being provided, right? But there is a hook on GORM that allows you to actually do something like this, like a before create. I can actually say, hey, this is going to be GORM. I'm going to do new. It's the same as when we were doing like the regular JDBC data. We needed to implement. I don't remember the interface, but that practically was using create a new, and we needed to override and create a new every time that there was a new employee, for example, right? So this is the way. This is one way to do it. The other is that here there is another parameter name like a default, and you can actually call the default. And you can do like that. The one that it was shown there, right? So that's kind of the idea of having these before create. It's just a hook, or you can do the other stuff. I wanted to test this, so this is one way to do it. Very good. So practically, we are done with our application. Now we need to start testing it. So in order to test, of course, what we need is to have CockroachDB up and running. So I already downloaded CockroachDB. So I'm going to do, I already have the whole thing. So it's going to be Cockroach start single node -- insecure. So I'm going to run it, right? Now let's take a look. It's already there. Very good. So of course we need to create our database, right? So we need to create another. I'm going to create another terminal. So for this, I have like a C. So practically, I have the Cockroach SQL insecure. So that's the way to connect the SQL kind of a terminal. So I'm already there. So if I do like a show tables, show databases, practically I have the default DB, the Postgres system, and of course I'm going to do create database payroll. So this is something that we need to do. So it's already there. So payroll is there. So practically, let's run the application. How to run it? We go here, and it's already have the play. So let's run it. Let's see if that works. Hope it works. Very good. And take a look. Employee payroll. Woohoo! My ASCII art. An excellent feature that every application must have, right? Very good. So something that I like to do here in order to test it, I like this kind of a way to use these features. I've seen that in VS Code, you can download the plugin from HTTP client, but here Golang from JetBrains has these kind of the same plugin. So practically, you do new HTTP request, and I'm gonna say employees, and you have practically a way to do your get your gets, right? So if I'm going to do, for example, the first one, get employees. So it's going to be get localhost 85 API employees. So if I execute it, I have my employees right here, right? So I have those there. Now, what happens if I go and even before I create one, let's test the one that I was talking about with Greg, right? Like let's do employees recent role engineer. So in order to do, of course, take a look. We have this, and we have Felipe as an advocate. We have Glenn as an engineer. So if I go here and execute this one, because I'm calling give me all the engineers, I have Glenn here, right? So that's okay. It's doing the as a system of time there. Now let's create a new one, right? So let's create. I have here, and of course, I'm not forgetting Greg. So practically, I'm going to do a post. So I'm doing the post. Greg is an engineer.
Aww.
If I do get employees, yes, I have everybody. But now if I do get by role, I only have Glenn. And that's one of the queries that is being executed. I don't know if you remember, we have over here on the employee these guy right here, right? So it's 30 seconds. Again, if I go here and do now I have Greg as part of the engineer, right?
You waited 30 seconds, yeah.
Yeah. So that's it. This is the application. This is a way to connect your app with your Golang, with a CockroachDB. Use the features. I know this is kind of a basic stuff, but we wanted to show you how easy it is to create these kind of applications. And of course, we're going to start creating all these playlists for you guys in order to have like, hey, this is the beginner, this is the way to do it, and we're going to start getting more advanced in the next sessions, right? So right now, the term was for Go. Probably next one we're going to do maybe .NET, or we can use the Python part. I think Greg will love to do that Python stuff. But yeah, that's how you create a REST API using GORM, right? GORM, the ORM library for Golang, and the Gene framework, right? Now, this particular project is already here in our Select Start Show repository. It's already here. So please go ahead and you can download it, play around with it. I'm using here HTTP Py, but I already put even the HTTP here. You can run it on VS Code or wherever editor you feel like. It's very, very simple. And remember, you can install CockroachDB, has to be there. You can download the binary, or you can use Docker containers, Dev containers, sorry, or whatever you feel like for your infrastructure. So that's it. Any comments, Greg?
This is looking really cool. I like this. And that's the thing. I wanted to let everybody know it's be sure, you subscribe here so you can catch this, because we're not just talking Spring stuff here. We're going all in, let's show all kinds of stuff, what we can do. And so I was super stoked when I said, hey, Felipe, you got a demo, you ready to go? What you got? And he was like, how about Go? And I said, okay. And I read the code. I flipped through the code. I said, this looks like every rule I know about Java flipped on its head. So it's like kind of a mind bender. So, but there's a lot of Go people. Did you know CockroachDB is fundamentally written in Go? So the actual database engine is written in Go. And so it's fun seeing that. Some of the stuff reminded me of my C++ days with pointers and references and stuff. And I've not touched that in a while. One of the things, if you're wanting to get your hands on it, there's a QR code here, or you can just visit university.cockroachlabs.com. There's some free courses you can take right here. We'll let you get your hands on for a little bit of introduction to CockroachDB, or just do what Felipe showed. Go to the Select Star Show GitHub org and download one of the chunks of code that we've got here to give it a shot.
Very good. All right. Let's see. Nice. Yeah, I was checking out the comments. Very good.
Yeah, I like that. That was good. So yeah, and this is a sort of this is what I call the developer oriented live stream that we're doing. There's other podcasts on the channel here. David Joy is one of the other content creators here. He's interviewing people. He does the big ideas in app architecture. So there's a lot of episodes where they're talking about kind of the big concepts that people are having to implement, like where do you use CockroachDB? Why would you want it? Whatever. So there's a lot of content there for that. And what we're trying to plug here is let's share it at the developer level. And so let's kind of hit the big stuff, and let's hit the stuff down here. And so if you're enjoying this, then you came to the right place. And I encourage you to subscribe to the channel where you can catch more. You got any other stuff here, Felipe?
No, excited for the new episodes, and bringing more and more another programming languages or any other technology. I was thinking on some event-driven architecture for the next time. That will be awesome.
We'll put it in the comments, the stuff you want to see us cover. If there's certain tech that you're thinking about, you would love to see demoed, post it in the comments, and we will see you next time.
This episode is over, but your learning has just begun. Visit cockroachlabs.com to find all kinds of content to expand your knowledge.